Good afternoon, class. So let's see the remaining part from the unit 4. We are talking about the unit 4, where we have discussed the basic idea about the classes, different types of relationship, that is starting from association, then multiplicity, then dependency, then generalization, then realization, then is a part of relationship that is either aggregation or composition. Aggregation is a weaker type of a relationship and composition is a stronger type of a relationship. Always remember with an example the relationship between engine and a car. Without engine you cannot drive the car. So the relationship between the car and the engine of a stronger type, we will use composition. And another example to understand is a part of a relationship between tire and car, means without tire or doors. Example is doors and car. So without doors, is it possible to drive the car? Yes, you can drive the car. For one car there may be a possibility of four cars, minimum two doors, like that. So that kind of a relationship you can discuss. Then we have discussed the common mechanisms to draw the class diagram, means how to complete the scenarios. Then we have discussed last lecture about the interface, concept of interface. Interface is nothing but what? Simply remember the concept of socket. So one electric socket having a properties of 5 ampere current and 230 voltage. So the same socket you can use to charge your mobile, same socket you can use to charge your laptop, or same socket you can use for making or just to connect your projector, for example. So the socket is same, that. So what you need to bring, you need to bring a proper interface. Now that proper interface means, if you want to charge your mobile phone, you should have a proper mobile charger with you. It may not be the case that though the socket is there, by using laptop cable you cannot charge your mobile phone. So it means you need to have a proper connection. That proper connection I am talking about interface. So interface is nothing but, simply remember, it is a plug and play architecture. So it is nothing but what I can say, it is simply plug play architecture. You bring different classes together, you bring different or elements together, perform some kind of an exchange of a data, and if you feel that the part is over, you can release the connection. That is, that type connection we can call simply as a interface. Then we have discussed different types and roles. For example, yesterday we have seen example of a teacher or professor and student. So professor conducting lectures. So the role they are playing, the role as a professor is a lecture, conducting the lectures for the students. That part we have discussed. Then we have discussed the basic idea about the packages. So quickly revise what does the package means. Yesterday also we have discussed. Today also we will just kindly revise the concept. We'll quickly follow the semantics to understand. This is what we discussed, interface. So interface is nothing but simply collection of operation that are used to specify a service of class or component. That may be a package, doesn't matter, it may be either class or component, only not limited to this. That may be a part of the system, or that may be the individual component, or that may be the subsystem. So graphically, an interface is represented as a circle in its expanded form. An interface may be rendered, that is represented either as a stereotype also. Inside the class notation also we can use. That two parts we have discussed in the yesterday's session. So see, interface I can represent either with this rendered, means can be represented with a circle, or I can represent with this also. This is simple class notation. But stereotype I have mentioned here as a interface. So that is what the simple way you can represent. This is the basic idea about the interface. Then interface relationship also we have discussed how we are going to record the scenarios and all. Then last lecture we have discussed basic idea about the roles, responsibilities. For example, I'm talking here the person and a company. So the relationship between this person and company, it may be that particular person may be an employee. So that is what roles. This is multiplicity. One dot asterisk marks means we can say star marks basically to understand. So this shows multiplicity. This is many, unlimited. Star means many. In one company, many persons are working. Person may work in either one company or maybe in association with other parts also. So that number also you can increase. So that is what the part we have discussed yesterday. Then we have discussed basic idea about the package also. So what does the package is? Package is nothing but it's a how to represent the package in UML. This is the simple package notation. Dog-eared rectangle you can say. So forming the group thickens. It can be used to group semantically related elements. So it defines the semantic boundary in the model, provided unit for parallel working and configuration management. So basically package is used to provide an encapsulated namespace within which all the names must be unique. So for example, analysis package, for example here, package is used to provide an encapsulated namespace within which all names must be unique. So analysis package contains use case analysis classes, use case realization, and a package syntax is shown in any form as figure number 1. So you can just read this figure, you can find out. See, this is one package called as what a membership, but inside the membership package you have many packages. So one has a members, club members, benefits, membership rules, joining rules. So these all are derived. I'm talking just as in a membership, but in what we can say generalized way can be represented simple package as a membership, but in detailed scenario where you can find out much more details. So see here, membership, to get the membership, what are the benefits they are going to get, all unique informations will be represented over there. So that is what we have discussed about packages. Object diagram also we have discussed, when to draw, where to draw the object diagram, what are the scenarios to complete the object diagram, and this is one more simple example to understand order management system. So this is order 1, order 2, order 3. uh, they are just giving number 12, number 32, number 40. Special orders, normal order you can record, and this is just as in a customer with their specialized note. So that's all about for the chapter number 4, and I ask you to complete one task, and the task was to complete one class diagram. So I hope you have all done. If not done, try to do with me. I'm just showing you how to complete it. So all of you just try to open the star UML part. Yes, all of you start working with this star UML. Any doubt regarding meanwhile chapter 4? Kindly go through the syllabus. If any doubt there, please let me know. Unit 4. Okay. So go inside, select the logical view. See, this is the package. Okay. Now I will add first package here just to show. Right click, add package. Okay. And package name I will give class diagram. For which, for what purpose we are going to draw the class diagram? We will complete the class diagram for employee management system. So class diagram management system. Select this. Now select this particular package. See here, I have added the package. Now select this particular package, right click, add a diagram and select the diagram, class diagram. Now I will rename a complete class diagram. Complete class diagram. So what you need here, you need basically, if you are remembering, we need almost 8 classes over here. So we will add one by one class. So select this first. The name of the class I am giving as an employee. Select this class. Simply give the name as an employee class. Okay. Okay. Then select one more class. Give the name faculty. Okay. Then we will have administrative employee as one more class. Administrative employee. We'll have one more class as a part of a employee only who will be working as a research associate. So select that particular class, add here research associate. Okay. After resource associate, we will have one more class regarding the faculty side. We will consider it as a institute. Consider them as an institute. Okay. Then next level we have as a part of a research associated, they need to conduct the lectures. So we will have one more class here. So I will add the class. I'll rename that class as a lecturer. And I will have one more class as a part of a course. And the last will be assigned with some project. So this many classes, if you are remembering the problem statement, you can read it one more time. What we are going to do, we are about to start. We are discussing the case study here. What is that case study if you are remembering? See here, this is the basic case study that we are discussing. We are trying to complete. This is a simple case study. You read it one more time. Just read it one more time for the understanding purpose. So university consists of multiple facilities which are composed of various institutes. Each faculty and each institute has a name. An address is known for each institute. Each faculty is led by dean, who is an employee of the university. The total number of employees is known. Employees have SSN, that is social security number, a name and email address. There is a distinction between the research and the administrative personnel. So these two roles are different. Next is research associates are assigned to at least one institute. The field of the study, each research associate is known. Furthermore, research associates can be involved in a project for certain number of hours. Means we need to assign some number of hours for the specific purpose of the project working. And the name, starting date and end date of the projects are known. Some research associates hold courses, then they are called lecturers. So course have a unique number, that is ID, course ID, name and weekly duration in R. So this is, I'm talking University Information System. So I will rename, by mistake I changed it. The package name I will give class diagram University Information System. I'll rename it University Information System. University Information System. The class diagram for the same also. This is what the package, and see the things will be arranged automatically inside that package. Okay. Now let's focus on one of the role, and based on the role we will discuss. Okay. So this employee will be as an abstract class. Okay. So I will consider, yes, it is an abstract. See here, when I select abstract, what happens here? Now I will add attributes and operations over here. So first attribute I will add as an SSN number. So I'm calling this as SSN, social secure number, SSN. With a type I'm giving as an integer. Okay. Then I will add name. That name will be in the form of string, and add one more attribute, that will be his email ID. So edit email ID. Email ID will be again string, data type will be string. Then we will add counter, that will be in terms of integer. Counter, that will be in terms of simple integer. So these many attributes will be there. Just for the simplicity, we will add this. Okay. Then we'll consider this faculty, where we can have the attributes, only one attribute for the simplicity. I can say name, that is the name. I will say simply name as an string. Okay. Let's say close this part. Now first we will discuss this, the relationship between faculty as an employee and the faculty. So we can say, we will start with simple association relationship. Okay, just they are associated. Okay. So this employee isn't just a generalized class, or we can say is an abstract class. Okay. So this, the relationship multiplicity, we can define them. So inside this multiplicity, select this particular association, bring your cursor down at the left hand side, you can find out this. So you can just discuss this multiplicity, and you can say the multiplicity simply as a 1. Okay, see 1. The role name, you can see that employee leads as an faculty. So the name I will give here, the role name, that is leads. And then you can discuss the multiplicity at the faculty slide, which can be either 0 or the 1. So I can say here multiplicity in terms, here I can say 0 dot dot 1. So see, this is the relationship. Okay. Then this will be, means employee may be working as a dean. So the specific name I can assign over here as an deans. So visibility by default public is specification. Yes, is specified. And I will say this visibility participant employee aggregation. and one name I will give here, and one name as an part will be considered as a dean. Give the name dean. See here, the role name I am giving as a dean. So this part is okay, done. I hope you all of you have done with this up to this. Any doubt, any query, please let me know. Okay. Now this will be considered at a top level because everyone will be there as an employee. There may be roles different, maybe administrative employee, maybe research associate, maybe lecturer, or maybe working on the project, but they will be treated as an employee. So employee becomes your super class. In this example, employee becomes your super class. Okay. Now with respect to the super class, we need to do the specific arrangements. Okay. So we will use a simple generalization relationship. So this generalization relationship, I'll show like this. Again, this research associated with this generalization. The lecturer will give with the generalization. So I'll complete this part. Generalization. Lecturer and course. There will be a bidirectional association relationship. I'll organize it. Okay. Then we will discuss the relationship. Okay. Research associated will be assigned with project also. So I will directly use association inside this as a project. Okay. So this is the basic part. Okay. Now how to relate the faculty and the institute. So there may be a stronger relationship between the faculty and the institute. Institute is the whole part. Faculty will be the part of the institute. So without faculty, there will be no institute like that. So I will use composition relationship over here. This is I will use as a whole and this as a part. Okay. So this will be the relationship. One faculty, and inside the institute you will have more than faculty. So association multiplicity you can say at the end one, exactly one you will have, and at the end two you can have multiplicity in the terms of 1.00 or 1 dot many. So this type of a relationship you can discuss. Yes. And here you can have one simple one. Similarly, the relationship between the research associate and the institute class. Okay, so institute class will have attributes like name and address. So let's add the attribute first. Okay, I'll add the first attribute as a name. I'll edit. I'll say name with string option, string, and I will add one more attribute that is with address. So add one more attribute, assign it with an attribute value of a type string. So say address in the form of type string. Okay. Then inside the research associated, we need to discuss the specialty. So attribute value that we will consider here as field of study. So I will consider attribute here as a field of study. Edit this. Field of study. where I will consider the data in the form of string only. I'll consider this as a string. Close this. Okay. Uh, the relationship that will be as a part, we can say that the relationship is one to many and one to many, but with a lower type of relationship. So we will use here aggregation. That will be simple aggregation over here, and the multiplicity that we can say as simple one to many, and here also one to many. Multiplicity will be in the form of one to many. So done this. Any doubt, please let me know. Be interactive. Okay. Then lecturer teaches the particular course. I'll assign the only name just for the understanding. Okay. Course. What are the parameters that we need to take into the consideration for the course? Like course must be have a name that will be unique name. So I will consider this as a name. Course must having name that will be in the form of string. Then course course must have id. Edit id. That id will be in the term of integer. Then I will add one more attribute, that is hours, because the course have 40 hours, 30 hours, like this parameters. So I'll consider this as hours. Number of hours, I will simply say hours, and that will be in terms of float. Okay. Close this. Then relationship, I will say simply and one name here, teaches, that is what the role name we can say. So lecturer teaches course, and relationship one to many, one to many. Here also, okay, so the second part, lecturer, you can say one to many. Okay. Then one most important part that we need to consider is a project. Inside the project, we again have the same attributes, that is project name, start date, end date. So add attributes. I'll name project name. So say name, that will be in the form of string. Then we'll have one more attribute here, add attribute, that start date, start, that will be in the form of date, start date we can say simply. And we will add one more attribute over here, add attribute, that is end date. So that will be considered as a project end date. Project end date in the form of date. Okay. So research associate will be assigned with the project. So they need to give specific hours. So I will consider them one project or many project. So simply I will assign the multiplicity for either maybe minimum one or maybe major projects, more than one projects. Or here for the single project, there will be at least maybe one research or may not be one research associate. So I'll consider the multiplicity here in the second part as an 0 or many. So I'll save this part. Okay. Now this will be considered, research associate participants will be considered with specific hours. so that our parts we need to take into the consideration. So how we can take that part into the consideration? Can anyone tell me? So we need to consider number of hours that will be participated. So I will add one more option over here just for the simplicity. Okay. Research associate participation is considered as one more class. Okay. So to calculate how much hours he will spend on the particular project, so I'll consider one more class over here, and that class will be associated with this participation. So I'll say project participation. Project participation. And it has only one attribute, and the attribute is talking about hours, total hours in terms of integer. We'll count total hours. I'll consider this with simple link. Okay. And that will be considered as a part of project implementation. So I'm connecting this. Yeah. So this becomes my class diagram completed. Any doubt, any query, how to complete it? Just simple drag and drop options. Read the problem statement and make sure that as per the problem statement, whatever the problem statement we have over there, so as per the based on the platforms, everything will be here or not. So just confirm this part. Okay. After completion of this scenario, the next feature part remaining is how to generate the code. That is what the part missing. That part now we will discuss. But please let me know if any doubt so far. Any query there? I hope all of you have completed this part, whatever the part I have shown just now. Is everyone completed? Shall we go for the next feature? Yes, please reply something yes, no. No reply there. Yes, Siddhi, okay, thank you. Okay, I will show you the most important part. Once your class diagram part is done, how to generate the code for the same. So you will get the code for your project. So let's see how to get the code. Move on quickly. Okay. So this is what, open your particular class diagram, and inside the class diagram, so based on your class diagram scenario, what we will do, make sure that you have added all the view inside this model, go to this profiles and select the language, in which language you want to generate the code. For example, I want to generate the code in Java profile. So select the Java profile, say include. Java profile has been included successfully, and say close this part. Save this. Okay. Now what you can do, you can select the particular class and then you can generate the code, or you can additional parts for individual class also you can, generate the code. So it's up to you how you consider the scenario. So I will generate the code for the whole class diagram. So I'll select all the classes, everything I have selected, right click, and you will get an option over here, the Java programs. Okay, so that is the one major part. Select the complete class diagram, select an option Java, and select the option generate code. I'll repeat what I'm telling. Select the particular class diagram for which you want to generate the code. Suppose I want to generate the code for this complete class diagram which I have drawn for University Information System. So select this particular class diagram, right click over there and select the option in which language you want to generate the code. So for example, in my case, I have selected an option as Java. So select the option Java and click on generate code option. So see here, for which particular package you want to generate the code. I want to generate the code for this class diagram. Say next. Okay, for all the objects you want to generate the code except the package one. Yes, I want to generate the code for all. So select this all classes and say next. Where you want to save the code, I will save it on a desktop. Okay, on desktop I will create one folder. So select the desktop, right click over there, you can create one folder over there, say next. Okay, uh, keep by default setting as it is. If you want to change this, you can change this, or keep by default setting as it is, say next. Okay, Java code generated successfully. So finish. See the files generated automatically. How many classes were there? For each class, we got the file. For example, I say simple first as an employee class. So see employee class. Edit this. Your code is here. See here. Public abstract class. Automatically the declaration becomes as an abstract class. Employee. What are the attributes were there? All the attributes you can just check out there. Integer, string, whatever you have mentioned in the diagram automatically come as a part of your coding scenario. So once your code is ready, almost architectural code is ready, only the logical part you need to take into the considerations. See here, public class, institute, public object, type as a string, then next name, string, public object, address will be considered as a string. Only you need to reorganize the scenario, and just by doing the small changes, see for all scenario you can have the code over here. Okay, so for example, see here, this lecturer no attributes over there, but now what I will do, I will do small changes inside the code, inside the lecturer code, and let's check whether it's get implemented inside the lecturer or not. So what I want to say, I will just make a small change inside the lecturer code, and let's see whether it is implemented inside the diagram or not. That part is called as what? Reverse engineering. Means you will make changes in the code and you will check whether the changes will be reflected inside the diagram or not. Okay, so I will see lecturer, add attribute. I will add attribute. I will name lecturer. Simply I will say ID. I will consider as an ID of a type integer. I will add one operation over here. Add operation. Operation conducts lectures. So select course. First to select the specific course, and that course will be based on course ID. So I'll consider integer again. Okay. Save this. Changes has been implemented. So right click, select and Java, generate the code. Keep by default setting as it is. Desktop. Next. Okay. So you have. Let's finish this part. So you have a lecturer class over here. Okay. The code has been generated for the lecturer. Select this. See, integer ID, select course has been get implemented. Now I'll add one more simple, what we can say, attribute here, and let's take whether it will be get reflected or not. I'll add public integer id, where I will say public integer employee number. I will say employee number. Okay, file save. So I made the changes in the code, not in the diagram. I made the change in the particular code. So let's see whether that will be get reflected here or not. So select the specific diagram. Inside that specific diagram, select the particular class. Select that particular class, right click, select the option Java and perform reverse engineering option. So that file is saved on the desktop. So select the particular file, lecturer, add, select that particular file, say next, inside the package, next, run. Okay, and say finish. See, one more class is associated as an employee over there, and you can check, see here, employee ID in the string format will be get generated. This is called as what? Reverse engineering. The way we completed forward engineering, similar way you can discuss the reverse engineering. And after completion of your class diagram and object diagram, you can say that your entire scenario for completion of your structural diagram will be done. So that's all about the structural diagram part, or structural modeling we can say. So any doubt there, please let me know. If any point missing from the syllabus regarding the structure modeling, let me know. Structural modeling, all the points, instance, object diagram, package, types, roles, interfaces, class diagrams, common mechanism, relationship, classes, everything we have discussed with the hands-on session also. So if any point missing, let me know, or else I will give you one task which you need to complete. So what is the task I'm going to assign you? It's a very simple one. The class that I will assign, just a second. हाँ सर क्लास चालू आहे संपलं की करतो. So what I'm going to do, I'm just going to assign you one simple task, and the task is, all of you are aware about the Facebook system. Select 5 basic functionalities from the Facebook system and define the class diagram describing the data and operations behind that 5 functions. The 5 functions means what? So for example, I open the Facebook account so that you can able to understand. Okay. So what are the functionalities that you can do inside the Facebook? The first is you can perform the login, you can perform the logout. Is it clear? Login, logout. Then you can create a post. Now to create a post, there may be different types, for images, for tagging the friends, for filling an activity and check-in, question answers. These are the functionalities that you can do inside the Facebook system. So select any 5 functionalities and define the class diagram. Accordingly define the attributes for the same and draw a complete class diagram for the same. So describe this simple scenario to understand the working parts of the given relationship. Is this clear? Take the note of this. You can take the screenshot. This is the small work I am assigning to you. Just a very small task. Your attendance. Roll number 1,
Present.
2. Roll number 2, 3, 4, 5, 6,
Present.
7,
Present, sir. 7.
8, 8, 9,
9 present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present.
15,
Present.
16,
Present, sir.
17, 17, 18, 19, 20, 21,
Present, sir.
22, 22, 23, 24,
Yes, sir.
25,
Present, sir.
26,
26 present, sir.
27,
Present, sir.
28, 29,
Yes, sir.
30,
30 present, sir.
31, 32,
Present, sir.
33, 34, 35,
35 present, sir.
36,
36 present, sir.
37,
37 present, sir.
38,
38 present, sir.
39,
39 present, sir.
40, 40,
40 present, sir.
41, 42, 43,
43 present, sir.
44,
44 present, sir.
45, 46, 47, 48, 49,
49 present, sir.
50, 50,
Present, sir. 50.
51, 51, 52, 53, 54,
54 present, sir.
55,
Present, sir.
56, 57, 58, 58, 59, 60, 60, 61,
61 present, sir.
62, 63,
Present, sir.
64,
Sir, roll
65,
number 46.
Present. What is time?
65,
65 present.
66,
46, sir.
Wait. 66 absent. 67,
Present, sir.
68,
Present, sir.
69,
Present, sir.
70, 70 absent.
28
Any
present, sir.
40,
Roll number 4. 28.
Sir, roll number 5.
28.
Sir, roll number 46.
46 done. 20,
28.
hmm.
Sir, roll number 3.
Roll number 3 is there,
Yes, sir.
70 is there,
Yes, sir.
Sir, roll number 58.
58,
Sir,
Sir, roll number 8.
roll number 8,
Sir, 70.
Sir, roll number 59.
roll number 1 by 1,
59.
59. Yes,
17.
okay. Next lecture basically we'll start with the unit number 5. Just small task I am assigning to you. What you need to do, काय करायचे तुम्हाला, फेसबुक सिस्टीम यू ऑलरेडी अवेअर अबाउट दॅट. सो अनालाइज द फेसबुक सिस्टीम, find out any 5 functionalities. What are the operations that you perform in the Facebook? So list any 5 operations, assign that 5 operations as a 5 different classes. Based on that 5 different classes, decide there at least 2 attributes to operations. So for example, in case of a login is one of the functionalities. So attribute I can consider as a user ID. Second attribute I can consider as a password. Inside the login, operations will be, so ask for the password, take the passwords, carry forward the password, like this, means user ID password. So based on that style, you need to decide a complete class diagram for any 5 functionalities of the Facebook system. So complete the diagram for the class of a Facebook 5 functionalities, and try to generate the code, and also try to have the hands-on on the same. So I'm assigning the simple task to you. What is the task I am assigning? Take any 5 functionalities from Facebook system, any 5 functionalities from Facebook system, and draw class diagram, generate code for same. This is the task I'm assigning to you. It's the homework. Take any 5 functionalities, that is 5 operations from the Facebook system, and draw the class diagram first with attributes and operations, and try to generate the code for the same. That is the homework right now I'm giving to you. Try to complete it within the next hour. Any doubt there? Any query? Shall we take a pause here? Reply something, yes, no. Okay, Dipti. We'll take a pause here. Thank you all.